On a warm day, why do water droplets accumulate on the outside of glasses and soda bottles?
The water does not seep through the container, but instead comes from the air surrounding it. Water vapor is the gaseous form of water that is in air below the boiling point of water. As discussed above, it takes a larger amount of energy to vaporize water. So the molecules of water in the air have more thermal energy than do the molecules in the colder glass. So when the water molecules strike the glass, they transfer much of their thermal energy to the glass. The colder water molecules join together to form water droplets on the glass. The process is called condensation. Condensation also occurs on window panes when the outside is cold and the interior air is warm and humid.
What is the zeroth law of thermodynamics?
The zeroth law is so obvious that it wasn't added as a law until after laws 1 through 3 were developed. It is based on thermal equilibrium between two bodies. As has been stated, if two objects have different temperatures, heat will flow from the hotter to the colder. If there is no temperature difference, there is no net heat flow. They will be in thermal equilibrium. The zeroth law states that if objects A and B are in equilibrium and B and C are in equilibrium, then A and C are also in equilibrium. Suppose object B is a thermometer. You put it in contact with object A. Heat flows until they are at the same temperature. You then move the temperature to object C. If the thermometer shows no change, then B and C are in equilibrium and we can conclude that objects A and C are at the same temperature.
What is an open circuit?
Circuit that is open so no charges flow.
How does Einstein's special theory of relativity affect momentum?
The same factor, y, that affected distance and time, affects momentum in the same way, that is relativistic momentum is ymv. Gamma is 1 at slow speeds and becomes large only when the velocity is near the speed of light.
What is a pitch?
Like loudness, a description of how the ear and brain interpret sound frequency.
What are complementary colors?
Pair of one secondary and one primary color that form what is close to white light.
What is a refraction?
Bending of light as it goes from one medium to another.
How can resonance cause crystal glasses to break?
Many years ago Ella Fitzgerald performed a physics experiment in an advertisement for Memorex, R. Audio tape cassettes. The company claimed that the famous singer could create a pure tone at just the right frequency to cause a crystal wine glass to break, and that the Memorex, R. tapes recorded and played back sounds so accurately that the glass would break both when Ms. Fitzgerald sang and when the recorded sound was played. Is it live or is it Memorex, R? was the advertising question. Although it is hard to think that glass is something that can bend. If you tap the rim of a thin wine glass you can hear it ping. The shape of the rim of the glass oscillates. When the amplified sound waves pushed on the glass it distorted its shape. Some of the kinetic energy in the sound wave was transferred into the kinetic energy of the oscillating glass. When the frequency of the sound wave matched the natural frequency of the glass, the amplitude of oscillation was large enough to shatter the glass. Sound can make glass break when amplified because the sound waves can cause the glass to oscillate and bend. When enough kinetic energy is used, the sound waves can distort the glass to the point where it cracks or shatters.
What do some of the metric prefixes represent?
Prefixes in the metric system are used to denote powers of 10. The value of the exponent next to the number 10 represents the number of places the decimal should be moved to the right. If the number is positive, or to the left, if the number is negative. The following is a list of prefixes commonly used in the metric system. Sundials are a very old way to tell time. While accurate, they are limited by the fact that they only work when the sun is shining.
What is a Celsius scale?
Temperature scale on which the freezing point of water is 0 degrees Celsius and the boiling point 100 degrees Celsius.
Is there a net force on a polarized object? And can it exert a net force on the charged object, like the cellophane tape?
Yes, because the electrostatic force is stronger at closer distances. Thus the attractive force between the unlike charges is stronger than the repulsive force between the like charges, and there is a net attractive force.
If not against a wall, How can you stand on your toes?
You naturally move your arms forward or bend forward to move your center of gravity forward.
How long does it take light to travel certain distances?
The table below lists some travel times for light. Some of the destinations above would require light to travel in a circular or curved path, which it does not do.
What is hydraulics?
Use of a liquid in a device, usually a machine such as a pump, lift, or shock absorber.
What is magnetic declination?
Magnetic declination is the angular difference between north as shown by a compass and the direction to the geographic North Pole, Earth's axis of rotation. Declination depends primarily on the location on Earth but, because the magnetic poles move, also on time.
What is the standard unit for mass?
The kilogram is the standard unit for mass in SI and the metric system. The kilogram was originally defined as the mass of 1 cubic decimeter of pure water at 4 degrees Celsius. A platinum cylinder of the same mass as the cubic decimeter of water was the standard until 1889. A platinum iridium cylinder with the same mass is permanently kept near Paris. Copies exist in many countries. In the United States, the National Institute of Standards and Technology, NIST, houses the mass standard, as well as the atomic clocks that define the second. The kilogram is the only standard unit that is not based on atoms or molecules. Several methods are under development to define the kilogram in terms of the mass of the carbon atom. Currently, one method has a precision of 35 parts per billion. That is equivalent to measuring the mass of your body. And the change in mass if one hair falls off your head.
What is a gamma ray?
High-energy photons emitted by some radioactive nuclei.
What are the frequency limits of the human ear?
The ear allows humans to hear frequency ranges between 20 Hz and 20,000 Hz. But it is most sensitive to frequencies between 200 Hz and 2000 Hz.
Do all elements have a fixed number of protons and neutrons?
The number of protons in the nucleus of an atom determines what element it is. So the number of protons is fixed. But, the number of neutrons can vary. Nuclei with the same number of protons but different numbers of neutrons are called isotopes. For example, carbon, with 6 protons, can have 5, 6, 7, or 8 neutrons. The isotopes are labeled carbon-11, carbon-12, carbon-13, and carbon-14. A more compact notation is 11C, 12C, 13C, and 14C. Chemical properties in general do not depend on the isotope. There are at least 3,100 isotopes of all the elements presently known.
How does force affect acceleration?
From your explorations you could draw the conclusion that when there is only one force exerted on an object, the larger the force, the larger the acceleration.
What is a stealth plane?
Stealth aircraft are planes that are able to avoid radar detection. The materials on the plane's surfaces and their peculiar shapes and angles deflect radar waves away from the plane. Or in some instances, the plane's outer fuselage can actually absorb the radar waves without reflecting it back to the enemy radar transmitter. Refer to the Fluids chapter for more information about aerodynamics and aviation.
What is a jelly donut, JD?
Informal energy unit. Energy in a medium-sized jelly-filled donut. 1 JD equals 239 kilocalories.
Why was Einstein more than just a world-renowned physicist?
Einstein supported unpopular causes. The year he moved from Switzerland to Germany, he joined a group of people opposing Germany's entry into World War I. He joined both socialist and pacifist causes. He opposed the Nazis, and when Adolf Hitler, 1889 to 1945, came to power, Einstein moved to the United States. He took a position at the Institute for Advanced Study in Princeton, New Jersey. Some years later he became a citizen of the United States. After being urged by other physicists, Einstein signed a letter to President Franklin D. Roosevelt, 1882 to 1945, pointing out the danger posed by Germany's work on uranium that could lead to a dangerous new kind of bomb. The letter helped to launch the Manhattan Project that led to the development of the atomic bomb. Although Einstein did not actually work on the bomb, after the defeat of Germany, and knowing the death and destruction that dropping the bomb would cause, he sent another letter to the president urging him not to use the bomb. The letter was never forwarded to President Harry Truman, 1884 to 1972. After the war, Einstein spent time lobbying for atomic disarmament. At one point he was even asked to head the new Jewish state of Israel.
What would happen if the cable holding the elevator would break?
You and the elevator would both be in free fall, accelerating at g. There would be no weight shown on the scale. You and the elevator would both be in the state of apparent weightlessness. We'll meet this term again when we explore the motion of satellites. The apparent weightlessness of astronauts will be explained there.
What is a wedge?
Simple machine used to force two objects apart. Examples are the knife, hatchet, or axe, and plow.
What are super high frequency, SHF, waves?
Frequency 3 GHz 30 GHz.
What is an umbra?
Area of the shadow where all the light from the source has been blocked.
What is a wavelength?
The distance from one point on the wave to the next identical point, the length of the wave.
What is the Bohr model?
A nuclear model but with electrons moving in only certain allowed orbits at discrete radii and with specific energies. When in these orbits their radii and energies are constant, the atoms do not emit or absorb radiation. Electrons gain or lose energy when they jump from one allowed orbit to another. Then they emit or absorb light with a frequency given by hf equals E2. E1 where E2 and E1 are the energies of the electrons in the allowed orbits.
What is the most aerodynamic shape?
Some think the narrower and more needle-like an object is, the lower its drag force will be. Although a needle head cuts easily through the wind, the problem emerges at the tail end, where the wind becomes turbulent and forms small eddy currents that hinder the streamline flow of air. The optimum shape depends on the velocity of the object. For speeds lower than the speed of sound, the most aerodynamically efficient shape is the teardrop. The teardrop has a rounded nose that tapers as it moves backward, forming a narrow, yet rounded tail, which gradually brings the air around the object back together instead of creating eddy currents. At high velocities, such as a jet airplane or a bullet may travel, other shapes are better. For turbulent flow, the least drag comes from having a blunt end, which intentionally causes turbulence. The rest of the air then flows smoothly over the region of turbulence behind the object.
What makes an object positively charged, negatively charged, or neutral?
The massive nucleus of an atom consists of positively charged protons and unchanged charged neutrons. It is surrounded by a cloud of negatively charged electrons. Normally atoms are neutral, the number of electrons equals the number of protons in the nucleus. A negatively charged object is an object that has an excess of electrons. A positively charged object has fewer electrons than protons in the nucleus.
What are examples of wheels and axles?
The screwdriver is one example. The larger the diameter of the handle, the greater the torque that can be applied to the screw. Many examples have a rope or chain wrapped around the axle. A sailing ship's steering wheel could be represented by either the left hand or the center drawing, depending on whether the helmsman pushed down or pulled up on the edge of the wheel. The rope around the axle is connected to the rudder, which is then turned to the right or left. A similar device would be a device to lift a bucket from a well. The wheel is then replaced by a crank, but the operation of the device is exactly the same. Again, the crank can either be pulled up or pushed down to exert a force on the rope to pull the bucket up. The rear wheel of a bicycle can be thought of as two wheels on an axle. The large wheel has a rubber tire and exerts a backward force on the road, while the smaller wheel is the sprocket that the chain turns. The right-hand drawing above shows that the force of the chain is larger than the wheel's force on the road.
What is acoustics?
Acoustics is the branch of physics that deals with the science of sound. Although sound has been studied since Galileo, 1564 to 1642, made some predictions in the early 1600s. The ability to study sound has grown tremendously in the past few decades because of the advent of electronic sound generators and measuring devices. In addition to the study of sound itself, the field of acoustics has several applied subfields. The most important being speech and hearing, architectural acoustics, and musical acoustics.
What is a reflecting telescope?
A reflecting telescope uses a mirror to gather light and focus the light toward the eyepiece. It usually consists of two mirrors, one large curved mirror at the end of the telescope to gather light and a smaller mirror used to direct the light to the eyepiece.
Why do most color inkjet printers use 4 colors to print, instead of the 3 primary colors for subtractive color mixing?
It would seem that a color inkjet printer mixing the 3 primary pigments of yellow, magenta, and cyan should be able to produce all the other colors, including black. When all 3 primary colors are combined, however, the mix looks more like a muddy brown color than black. Although these are the primary colors of which other shades can be created, they do not represent all the colors of the spectrum needed to form black. That is, there are gaps in the wavelengths that these pigments absorb. Therefore, most color inkjet printers have a cartridge with yellow, cyan, and magenta ink, and another separate ink cartridge of just black.
What is tensile strength?
Maximum tension force that can be applied without breaking object.
What is the chemical energy?
Potential energy of a system due to its chemical composition. A chemical change can cause this energy to be changed into or out of other forms. Animal bodies and batteries are 2 common objects that have chemical energy.
What is nearsightedness and what can be done to correct it?
Nearsighted vision means that a person can only clearly see objects that are relatively near the eye. Images from distant objects are focused in front of the retina. Nearsightedness, or myopia, is most often caused by a cornea that bulges out too much. The lens cannot be flattened enough to compensate, and so distant objects appear fuzzy. To correct for the short focal length of the lens, a concave lens is used to make the light rays diverge just enough so that the image will fall on the retina. So contact lenses to correct for myopia are thicker at the edges than at the center.
What is fluid statics?
Study of fluids in a state of rest.
What is the threshold of hearing?
Minimum sound intensity that can be heard, 0 dB.
What is a trough?
The lowest point of a transverse wave.
What is color blindness?
Some people are unable to see some colors due to an inherited condition known as color blindness. John Dalton, 1766 to 1844, a British chemist and physicist, described color blindness in 1794. He was color blind himself, and could not distinguish red from green. Many colorblind people do not realize that they cannot distinguish colors. This is potentially dangerous, particularly if they cannot distinguish between the colors of traffic lights or other safety signals. Those people who perceive red as green and green as red are known appropriately as red-green color blind.
Are holiday lights in series or parallel circuits?
Many years ago holiday lights used large bulbs designed to work on 120 volts. Those strings were wired in parallel. Today holiday lights are wired in series so that the tiny bulbs have only low voltages across them. If a lamp burns out because the filament fails, there will be no current through the string. But, there will be 120 volts across the failed bulb. The bulb has a wire touching the two thick wires that deliver current to the filament. The wire is covered with a thin insulating film.
What is an electroscope?
A device used to measure electrical charge on an object.
What is the difference between analog and digital signals?
All transmitters create what is called a carrier wave at a specific frequency. For licensed commercial broadcasters, the Federal Communications Commission, FCC, assigns the frequency. The carrier wave transmits no information. For information to be carried, some property of the carrier wave must be changed. The earliest methods of radio broadcasting used analog signals from a source like a microphone. Sound striking a microphone produces a varying voltage output. That is, the output of a microphone has the same shape of the amplitude of the sound wave that strikes it. The smooth graph below represents an analog signal from a microphone. To create a digital signal, the analog output of the microphone is converted into a series of numbers. For example, consider the graph above. Suppose the signal is sampled every 2000 times each second. That is, the voltage is recorded each 0.5 millisecond. The dots show the results of the sampling. Voltage can be in only whole numbers. The series of numbers representing the waveform would then be those shown in the table. Next, the voltages are converted into binary digits, a series of zeros and ones. The table on the right shows the conversion to binary for numbers 0 through 7. The binary digits reading left to right represent the numbers 4, 2, and 1. Thus 5 equals 4 plus 1 or 101. Now the binary numbers are converted into a series of voltages to be sent to the transmitter. One method is called pulse width modulation or PWM. A narrow pulse represents a 0, a wider pulse represents 1. For example, the first 4 samples would produce the following wave train. The receiver knows that 3 bits should be converted into a number. If the receiver is to convert the signal back to analog, then that number determines the amplitude of the analog wave.
What happens if the two forces are in opposite directions? What happens if both forces are equal? If one is stronger than the other?
If they are both equal, the car will remain motionless. That is, it will act as if there is no force on it. If one is stronger than the other, then it will move in the direction of the smaller force, but it will accelerate less. That is, the results will be the difference between the two forces. We'll explore forces that act in different directions later. Physicists say that the combination, addition, or subtraction of forces produces a net force, and it is the net force that affects the acceleration. Thus Newton's laws should be written as follows. Newton's first law: if there is no net force on an object, then if it was at rest it will remain at rest. If it was moving, it will continue to move at the same speed and in the same direction. Newton's second law: if a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnet/m. Or, Fnet equals ma. Couch is heavier, the opposing force will be larger. The amount of force opposing you will depend on the surface the couch is on. A carpet will have a stronger opposing force than a smooth surface, like wood or tile. These observations summarize the properties of friction between two objects that are in contact. Friction is always in the direction opposite the motion. Friction is greater if the moving object is heavier. Friction is greater if the surface is rougher. But, friction does not increase if the speed of motion increases.
What is tension force?
Force that pulls an object apart. See tensile strength.
What is momentum?
The product of mass and velocity p equals mv, vector.
Why do we need to introduce momentum and energy? Aren't Newton's laws good enough?
Newton's laws could be used, but when you analyze the motion of more than a few interacting objects, Newton's laws are just too complicated. When you use momentum and energy, you concentrate on the beginning and end of an interaction, not on the details of the interaction. A sports team can be said to have momentum.
What is the newest hybrid of bridges?
One of the newest, prettiest, and most economical bridges is the cable-stayed suspension bridge. With its sleek lines and thin roadways, it is the perfect bridge for most mid-span designs. The Tatara Bridge, in Onamiki, Japan, completed in 1999, is the longest cable-stayed bridge in the world, with a span of 890 meters, 2,919 feet. Cable-stayed bridges suspend the roadbed by attaching multiple cables directly to the deck supporting the roadbed. These cables are then passed through a set of tall vertical towers and attached to abutments on the ground. Such engineering methods reduce the need for heavy, expensive steel and the massive anchorages that are needed to support suspension bridges.
What is a block and tackle?
Simple machine that is a combination of fixed and movable pulleys.
What supplies this centripetal force?
Centripetal force must be supplied by something or someone exerting the force on the object. In a rotating drum ride at a carnival, you stand with your back on the drum. As the drum speeds up, you can feel the force of the drum pushing on your back toward the center of the circle. Often the floor drops down and only the force of friction between your back and the drum keeps you from dropping down with the floor.
What is convection?
The motion of a fluid, usually air or water, due to a difference in temperature. An efficient means of heat transfer.
Can a microwave oven be used to dry things?
Since water molecules are warmed and eventually boil off by microwaves, anything that is wet can be dried in the microwave. However, there is one very important consideration that must be made before placing The object inside a microwave, the object being dried, must not contain a great deal of water itself. Microwaves are wonderful at drying wet books, papers, and magazines, but must never be used to dry things like plants or small animals. Living things would be killed by the resonance of water molecules inside their bodies.
What is a motor?
Converts electrical to mechanical energy. Current through multiple loops of wires on the armature in. A magnetic field causes a force that results in rotation.
How is a second measured?
Atomic clocks are the most precise devices to measure time. Atomic clocks such as rubidium, hydrogen, and cesium clocks are used by scientists and engineers. When computing distances with global positioning systems, GPS, measuring the rotation of Earth. Precisely knowing the positions of artificial satellites, and imaging stars and galaxies. The clock that is used as the standard for the second is the cesium-133 atomic clock. The measurement of the second is defined as the time it takes for 9,192,631. 770 periods of microwave radiation that result from the transfer of the cesium-133 atom between lower energy and higher energy states. The second is currently known to a precision of 5 × 10⁻16, or 1 second in 60 million years.
What is pneumatics?
Use of a compressed gas rather than a liquid in a hydraulic machine.
How can you get circular motion?
If an object moves in a circle, either a planet, a satellite, or even a ball on a string twirled around, then there is no change in speed as it moves around the circle. So there can be no force in direction of motion. There must be a force, because the direction of the ball is changing, so its velocity is changing. The force must be perpendicular to the motion. Try to make a ball move in a circle. This works best with a ball the size of a soccer ball or basketball on a smooth, wood or tile, floor. Start the ball moving, then kick it gently in the direction perpendicular to its motion. Try another kick or two. Note that its direction changes. In the direction of the kick, the momentary force you placed on the ball. If you could exert a constant force that is always perpendicular to the motion, the ball would move in a circle. Note that the direction of the force is always toward the center of the circle. Such a force is called centripetal, or center-seeking. The force required to keep an object moving in a circle depends on three quantities. the mass of the object, the speed of the object, and radius of the circle. The force must be larger for larger mass, greater speed, and smaller radius of the circle.
How was the plutonium bomb used?
The plutonium bomb, named Fat Man for its shape, was dropped on the city of Nagasaki, Japan. On August 9, 1945. It contains 6.4 kilograms, 14 pounds, of plutonium-239. About 20% fissionide. And less than 1 gram was converted into energy with the equivalent of 21,000 tons of TNT. As many as 80,000 people were killed in the attack.
Was this animal electricity the same as static electricity?
According to legend, the Italian physician Luigi Galvani, 1737 to 1798, was making frog leg soup for his sick wife. Whenever a nearby static electricity machine created a spark, the legs jerked. After completing several experiments, in a 1791 paper, Galvani reported that when one metal touched the muscle of a frog's leg while another metal touched the nerve, the muscle contracted. Thus Galvani helped to show that there was a connection between static electricity and electric effects in animals.
What is a impedance matching device?
Placed between two media to create a smooth impedance transition. To maximize energy transfer by the wave through the interface. A transformer.
Does this look like the original analog signal?
No way. Note that there are two problems. First, the wiggles in the wave are missing. Second, with only 8 choices of voltages, the vertical resolution is too small. To make a more accurate conversion, you need to sample the wave more often. At least every 0.1 millisecond, and to allow more than 8 voltage choices, 32 or more would be better. To obtain the quality of sound in a CD, the sampling interval is 22 ℏs. 22 microseconds, and there are at least 4096 voltage choices.
Is energy conserved?
While total energy is conserved, the kinetic energy before the collision is much greater than the energy afterward. Much of the energy goes into bending metal and breaking glass and plastic. Automobile crash reconstruction is a way of using conservation of momentum to figure out the speeds of one or both of the cars before the collision. Kinetic energy is not always converted to other forms of energy in collisions. The toy Newton's cradle has a set of steel balls that swing on strings. In these collisions, kinetic energy is almost totally conserved. The incoming ball stops when it hits a second ball, and the second ball moves away with the same speed. And thus kinetic energy, as the incoming ball had. Collisions of pool or billiard balls is another case where kinetic energy is conserved. This kind of collision is called elastic, while the case of cars colliding is called inelastic. A hot object has thermal energy. How can it transfer this energy? What happened to the increased thermal energy of the eraser and your hand, or to the block and the table? A short time later all will have cooled. They have transferred their thermal energy to the cooler surroundings. Energy transfer that results from a difference in temperature is called heat. Heat always flows from the hotter energy sources to the cooler objects, energy receivers. Thermal energy can be transferred in three ways: conduction, convection, and radiation. Conduction occurs when two objects are in contact, like when you put your hand in hot water. Convection is the motion of a fluid, usually air or water. The fluid is heated by the hotter object, then moves until it contacts a colder object where it heats that object. You can think of convection as two instances of conduction. Radiation is infrared waves that are emitted by hotter objects and absorbed by colder ones. You can feel radiation if you bring your hands near a hot electric burner on a stove. The sun heats Earth by radiation.
What do radio astronomers hear?
Radio astronomers detect what sounds like noise, but is actually signals from atoms, molecules, and ions in stars, galaxies, and particles in interstellar and intergalactic space. In order to detect these signals, radio telescopes are used. These are shaped like large satellite dishes, and are able to detect wavelengths between 1 mm and 1 km.
What are total internal reflection and critical angle?
Total internal reflection occurs when a ray of light in a medium with a higher index of refraction strikes the interface between that medium and one with a lower index of refraction. When the incident rays are at a small angle with respect to the perpendicular to the interface, the rays pass through the interface being refracted to a larger angle. As the angle of incidence increases, so does the refracted angle. At the critical angle, the refracted angle is 90 degrees, that is, the ray's direction is along the interface. If the angle of incidence is increased any more, there is only a reflected ray. The refracted ray no longer exists. Because all the light is reflected, it is called total internal reflection.
What are possible replacements or additions to the Standard Model?
One proposed replacement is called supersymmetry. Each boson in the Standard Model has a supersymmetric fermion partner particle, or sparticle. And each fermion has a supersymmetric boson particle. They are called sleptons, squarks, gluonios, and photonios. These sparticles must be much more massive than the Standard Model particles. At least 480 billion electron volts. At this time there is no direct evidence of their existence. Although the LHC might be able to reach high enough energies to find them. A second replacement is string theory. String theory requires a 10-dimensional spacetime rather than the normal 4-dimensional spacetime. 3 spatial dimensions and 1 time dimension. A string is a tiny closed loop, like a rubber band. In some theories the loop can break into an open length, like a piece of yarn, but in others it cannot. Strings vibrate at characteristic frequencies, like guitar strings. Each vibration frequency corresponds to an elementary particle. If a string theory is to include fermions, quarks and leptons, supersymmetry must exist. The great advantage of string theory is that the graviton, the particle that carries the gravitational force, is naturally accommodated. But, if string theory is to be a theory of quantum gravity, then the size of a string must be the size of the so-called Planck length, 1.6 x 10 to 35 m. That is an unimaginably small length, 10 to 20 as large as a proton. String theories, however, contain symmetries that make their effects felt at larger distances. At this time there is no experiment that could test string theory. If supersymmetric particles are found, then string theory may garner more support.
What is a lunar eclipse?
Occurs when Earth casts its shadow on the Moon. Earth must be directly between the Sun and the Moon.
What is Kepler's third law?
The square of the period of the planet is proportional to the cube of the radius of the orbit.
What is a secondary rainbow?
Reversed color spectrum caused by an additional reflection of the light inside water droplet.
What is medium frequency, MF, waves?
Frequency 300 kHz 3 MHz. What is a megahertz? Megahertz, dash 1 million Hz.
What is nuclear fission?
Radioactive nuclei can decay in another way, they can split in two. This process is called spontaneous fission. Fission can also be produced artificially by bombarding nuclei with low-energy neutrons. In fact, fission was discovered in this manner.
What is a photon?
Packet of light energy, light quantum, by Einstein in 1905. Given name: photon in 1926. Has no mass or charge, but carries angular momentum. Always moves at the speed of light.
What is a gas?
State of matter in which the atoms are about 10 times further apart than liquids or solids, and forces between them are very weak. A fluid that assumes the shape of its container.
What levels of current are dangerous?
Approximately 1 mA, 0.001 A, is enough to produce a tingling sensation. 10 mA is painful. 12 to 20 mA is enough to paralyze muscles, making it impossible to let go. 60 to 100 mA causes ventricular fibrillation of the heart. That is, the heart is beating in such a way that it cannot pump blood through the circulatory system. Greater than 200 mA causes the heart to clamp down and stop beating.
What is kinetic energy, K or K?
Energy of motion, K equals 1/2 mv2.
What is latent heat of vaporization?
Energy involved in change from liquid to gas.
What is the threshold of hearing?
Minimum sound intensity that can be heard, 0 dB.
What is an energy transfer?
Requires a source, whose energy is reduced, a means of transferring the energy. And an energy receiver, whose energy is increased.
Are atoms indivisible?
thanks to the invention of the electric battery in 1800 by Alessandro Volta. 17451-827, chemists had a new tool to create reactions and isolate new elements. Sir Humphrey Davy was one of the most active and isolated sodium, potassium, and calcium from their salts. But it was his assistant, Michael Faraday, 1791–1867, who most contributed to the discovery that the atom was not indivisible. He found that the amount of charge needed to liberate an element from a solution was proportional to the mass of the element. In modern language, the amount of charge was proportional to the number of atoms liberated. It took until 1881 for the import of this result to be realized, when Hermann von Helmholtz, 1821–1894, pointed out that if elements are composed of atoms, then electricity could be divided into portions that could be called atoms of electricity. George Johnstone Stoney named these atoms electrons. But what were they? How was the electrical atom, the electron, discovered? Further advances came not from electrolysis but from studies of gases. In the 1700s and early 1800s, physicists used the vacuum pump, invented by Otto von Guericke in 1690. To reduce the pressure in glass tubes fitted with electrodes to allow electricity to pass through the tubes. In 1838, Michael Faraday passed an electric current through such a tube and noticed a strange arc-shaped light starting at the cathode, negative electrode, and ending almost at the anode, positive electrode. When Heinrich Giesler was able to reduce the air pressure to about 1/1,000 of an atmosphere, he found that the tube was filled with a glow, like the neon lamps used today. By the 1870s, William Crookes was able to reduce the pressure to 1/1,000,000 of an atmosphere. As the pressure was reduced, the glow gradually disappeared. Instead, the glass near the anode began to glow. Without air to disrupt their passage, rays of some sort were able to travel from the cathode to the anode. At the anode end, they were going so fast that they caused the glass to glow or fluoresce. By coating the glass with zinc sulfide, the glow was made brighter. The mysterious invisible rays could be shown to travel in straight lines by placing metallic objects in the tube and finding that they cast sharp shadows at the anode. Because the rays came from the cathode, they were called cathode rays. Joseph John, J.J. Thomson, 1856–1940, conducted 3 experiments with Crookes tubes that showed the nature of cathode rays. His first experiment used an electrode at one side of a tube, out of the direct path, which was connected to an electrometer that could detect electric charge. Thomson could deflect the path of the rays using a magnet and follow their path by observing the fluorescent glow on the tube's surface. He found that the electrometer showed a negative charge, but only when the rays were deflected onto its terminal. Thus he showed that the rays consisted of a beam of negative particles. Using a tube with the best possible vacuum, Thomson next explored the effect of an electric field on the rays. He added 2 parallel metal plates to the tube, connected a battery across the plates, and found that the rays were attracted toward the positive plate and away from the negative one. In his third, and most important experiment, done in 1897, he combined the deflection of an electric field with one by a magnetic field. In doing so, he could calculate the ratio of the mass to the charge of the particles. He found that this ratio was 1,800 times lower than that of a positively charged hydrogen ion. Thus the particles must be either very light or very strongly charged. He later showed that they had the same charge as the hydrogen ion, and so they were very light. Further experiments showed that the particles had the same properties no matter what metal was used for the cathode or whether the cathode was cold or incandescent. For his work, Thomson was awarded the Nobel Prize in 1906. The charge of the electron was measured in 1909 by American physicist Robert Andrews Millikan, 1868 to 1953. Before Millikan's experiments, some physicists claimed that Thomson's results could imply that electrons had an average mass-to-charge ratio given by his experiments, but that they could have a variety of masses and charges. But Millikan showed that all electrons had the same charge, and thus the same mass.
What is weightlessness?
Weight is defined as the force of gravity. Strictly, then the only way one can be weightless is to be so far from any massive object, like a planet or star, that the gravitational field is zero. No human has achieved this state. In a satellite, the gravitational field is about 80% as large as it is on Earth's surface. So the force of gravity on an astronaut in the satellite is not much smaller than it is on the astronaut on Earth.
When a car makes a turn, what supplies the centripetal force on it?
The road supplies this force. The road is in contact with the tires, and friction between the tire and road is necessary for the force of the road to be exerted on the car. If the road is covered with ice, the friction often isn't large enough and the car goes straight, rather than along the curve. A racetrack is often banked, so the tilt of the track can supply at least part of this inward force, reducing the need for friction. If you're sitting in the car, there must be a sidewise force on you so that you stay with the car as it makes the turn. Usually the friction between you and the seat is sufficient, but sometimes you have to hold onto the door handle to exert more force.
What is a lunar eclipse?
A lunar eclipse occurs when Earth is directly between the Sun and the Moon. Earth blocks the Sun's light rays from hitting the Moon, leaving it in complete darkness. For an observer on Earth, a shadow appears on the moon, causing it to become dark. As Earth moves out from between the Sun and the Moon, the Moon is gradually illuminated until the entire full moon is seen again.
What is the universal gravitational constant?
Proportionality between gravitational force between two objects and gmm/r2.
What is an apparent weightlessness?
Occurs when an object is in free fall. Force on object in direction opposite gravity is zero.
What is velocity, v?
Displacement divided by the time required to make the change, vector.
Why do we see specific colors?
When we see colors, we are seeing only part of the spectrum of colors that make up white light. The rest of the spectrum is missing. Selecting the color seen can be done in three ways. You can view the object through a transparent material that transmits only some part of the spectrum while absorbing the rest. The object may be colored itself. That is, it reflects part of the spectrum while absorbing the rest. Finally, the spectrum can be physically separated, as it is by interference or by refraction by a prism or rainbow. For example, theatrical gels on spotlights produce colored effects for a stage show. Snow reflects all of the spectrum so it appears white. But green paper reflects only the green part of the spectrum. A black cloth absorbs all light, and so it appears black.